You know that mysterious substance that makes up around 85% of the total mass of the whole freaking universe? Yes, dark matter. We just detected some of that stuff, and it's 12 billion years old. How cool is that? A collaboration led by scientists from Nagoya University in Japan used a fossil relic left over from the Big Bang to perform the earliest detection of dark matter ever. They detected dark matter distribution around Lyman-break galaxies, which are basically star-forming galaxies at high redshift. A redshift is an increase in the wavelength. The farther galaxies are, the longer the light's been traveling to us, and thus the longer the wavelength. This also means we're looking way back in time, in this case, 12 billion years ago. Observing dark matter is very tricky, mainly because dark matter doesn't emit light. This substance also doesn't even interact with ordinary matter and light. Astronomers used a cosmic signal sent out shortly after the Big Bang to map how dark matter was distributed around those ancient galaxies. Before you ramble about how dark matter doesn't exist and we don't even know what it is and scientists are delusional, let me explain what really happened. So there's a source galaxy that's even further away than the galaxy whose dark matter scientists want to study. The gravitational pull of the foreground galaxy, along with the dark matter surrounding it, distorts whatever's around it, even space and time. The foreground galaxy kinda acts as a natural lens, and this is predicted by Einstein's theory of general relativity. As light from the background galaxy passes through the foreground galaxy and the distortion around, it bends and thus changes the apparent shape of the background galaxy. Crazy, right? And the more dark matter you have there, the more distortion one can expect. So this is how scientists use distortion to measure the amount of dark matter around the foreground galaxy. But this method works only if the source galaxy is bright enough to actually pour light on the lens galaxy. Usually, these distant galaxies are very dim, meaning scientists have struggled to analyze dark matter in galaxies before around 8 billion to 10 billion years ago. However, in order to see even farther back in time, instead of galaxies, the Japanese team used a more distant light source, the cosmic microwave background, or CMB, which is the leftover radiation from the Big Bang that permeates the whole universe. The CMB can be distorted just like light. The team used microwaves observed by the European Space Agency's Planck satellite to measure how the dark matter around the lens galaxies distorted the microwaves. This is the first time that humans are measuring dark matter from almost the beginning of the universe, 12 billion years ago. During that time, things were very different. There are far more galaxies in the process of formation than today. Also, during that era, the first galaxy clusters were just starting to form. These clusters are made of between 100 and 1,000 galaxies, bound to large amounts of dark matter by gravity. The new study also reveals dark matter in the early universe is less clumpy than predicted by many current cosmological models. This could completely change our understanding of how galaxies evolve and suggest that the fundamental rules governing our universe could have been different when the universe was just 1.7 billion years old. To reach this conclusion, the team used data originating from the Subaru Hyper Suprime-Cam survey, which analyzes data from a telescope in Hawaii. But since researchers have only used a third of this data, a better map could be available soon.